because I remember doing problem 90 some time ago. It was a different question. The temperature of a person during an intestinal illness is given by temperature of time as negative 0.1 t squared plus 1.2 t plus 98.6, and t is a number between 0 and 12. Where t is the temperature in degrees Fahrenheit, of course, and t is, not time, but days. T is in days. Find the relative max and sketch the graph. No, we're not ready to sketch the graph. Not yet. I'm not going to do that. We need more information to be able to sketch the graph. Okay, so right now we are interested in the critical number. And we know that the critical number or critical numbers come from t prime of t0 or t prime of t being undefined. Well, we are talking about a polynomial function. That's not possible. So when I find t prime, I get negative 0.2t plus 1.2, and I set it equal to 0. And then t will be negative 1.2 divided by 0.2, which is 1.2 divided by 0.2, which is 6. 12 divided by 2. I multiply top and bottom by 2, so 6 days. So I know this function has a critical number, which means it potentially has a max min. I don't know yet. You can say, I know it. It's a quadratic function. I learned this when I was a kid. True. But in the sense that we are practicing, what we're trying to practice and see is, let's say we don't see that. Okay, so then I have t, and this is specifically between 0 and 12. We got 6, so this is t prime of t, and this is t of t, and it's 0 here. I have to plug in t6, and I'm going to do it right this moment. Negative 0.1 times 36 plus 1.2 times 6 plus 98.6. And I got 102.2. Okay. And now at this point, I need to study the sign of the derivative, which is t prime of t negative 0.2t plus 1.2. I know this is a linear function. It looks like this. It has to come from positive and go to negative. Just plug in 0 and you get it's positive, and plug in 12 and you'll see it's negative. So this is, of course, increasing and then decreasing. And now we know that the 0.6 days, comma 102.2 Fahrenheit represents what? It represents a local
max.
Thank you very much. A local max indeed. Any questions? Okay, let's look at one more, and then I'll stop. I know we have 10 more minutes. Maybe you still have some questions for me. I wanted to look at anything else but quadratic. So we've seen a quadratic function, but something else is more interesting. 87 on 202. Last problem for today. So according to the U.S. Bureau of Labor Statistics, the number of managerial and professional employees since 2006. Now, these days everything is messed up, so I don't know if the formula still applies. It doesn't matter. This is our exercise. Minus 971.369 t squared plus 2657.917 t and plus 50347.833. Okay, where t is the number of years since, so t equals 0 for the year 2006. And is thousands of employees. in thousands. Okay, find the relative extrema of this function and sketch the graph. No, we're not ready for sketching the graph. Interpret the meaning of the relative extrema. Fine. So in order to find the max min, I have to first find critical numbers if they exist. If they don't exist, there is no extrema. So I have to determine E prime of t, and that's going to be a little bit 107.833 and multiplied by 3. As you see, I'm a little lazy. 323.499 t squared minus 971.369 multiplied by 2, 1942.738 t, and then plus 2657.917. Good. I will have to find this, and it is very possible to find a solution with this, but I am more used to my other calculator. Never mind, let's do this together. So I think one of your colleagues showed me how to do it here. So I think it's under applications, and it's the polynomial. It's number 9, or you just select 9. And it's a polynomial root finder, and the order for this is degree 2, so I have to keep 2. And next, the leading coefficient 323.499, enter, and this is minus, and now I enter 1942.738, enter, and plus, yes, it's plus, and I want this 2657.917, and enter, and solve. So it gives us T1 2.108 and T2 3.897, and these are years since 2006. Okay, perfect. So then I will create my table. Since t is number of years, I'm going to say this. So this is 2.1 and 3.9, and this is E prime, and this is E of t. Yes, I have to plug those in the function, however, and I'm going to clear this and put the function 107.833 x to the third power, and then minus 971.369 t squared plus 2657.917 x, and plus 50,347.833. And now second and plug in. I'm plugging in 2.1 and I'm plugging in 3.9. Okay. So let's see what I got. I got for 2.1 52644, and for 3.9 I got 52336. Okay. 0 here and 0 here. And now I'm looking at the sign of this. When I plug in 0, I get positive. When I plug in 2.5, when I plug in 2.5 in the derivative, I know it's going to be negative. How do I know? Is because the function has a positive leading coefficient, the derivative, which we do not have to graph. So in between, you can check later, this must be negative and outside must be positive. So then this is the situation. So the question was trying to find, we're asked to find the points of extrema. So 2.1, so 2006, 2008, in other words, 52,644,000. So this is 52 million employees or people. And the other one, so this is a local max. And the other one was 3.9, which means 2006 plus 3.9, roughly 4. So in 2010, 52,336 thousands of employees. So this appears to be a local minimum.